Hello guys, welcome to our channel. I am Lara, and in this video we are going to solve a GAMS model for quantitative analysis. If you haven't watched my video or quantitative analysis to see which question we are solving, please watch that video first. Okay, so let's get started. So when we are solving a GAMS model, we have to start with our indices like how it is for the manual model. So we are going to set indices. So we had facilities, I, and then which facilities were those? A, B, C, and D. Okay, and then we had zones, which was J zones, and they were north, central, and south. Okay, when we are done with our clusters, let's say, so with our sets, our parameters, tables, equations, we have to let the system know. And how we do that is we put an Oxford comma after every cluster. Okay, so I am done now with my indices, so I put a Oxford comma. So now we are going to our parameters. Okay, so our first parameter was the facility capacity. And because the facility capacity is about the facilities, I'm going to use I, because I is facilities. So what was that? Facility capacity. And capacity of A was 80. Capacity of B was 60. Capacity of C is 80. And capacity of D is also 80. Okay, so then our next parameter is the demand. And demand has to do with the zones. Demand, I'll put the E here so the system doesn't confuse it with this one maybe. Okay, so what was our demand? Demand of north was 90. Demand of central is 70, and demand of south is 60. Okay, so now that we're done with our parameters, I'm going to put an Oxford comma here also. Okay, so now we are going to have to write our costs. How we do that is we make a table of C and then IJ, so cost of going from I to J, so from facilities to zones. So we have north, we have central, we have south. Okay, then we have A. From A to north, it cost us $4. From A to central, $8. From A to south, $10. And then B to north, it cost us $7. B to central, it cost us $6. And B to south, it cost us $9. Then we have C to north, $6. C to central, $5. C to south, $4. And then D to north, it costs us $5. D to central, $7. And D to south, it costs us $6. Okay, so now I'm done with the table. I'm putting a Oxford comma here also. Now we are going to write our variables. At first, we have our variable Z. Then we got our positive variable because what we are shipping cannot be negative, positive variables. And when we write it this way, it also means that this is actually our non-negative constraint. And then we are going to get a binary variable. Why? Because we're opening C or we are opening D. So we are opening C or not. We are opening D or not. Binary variable. And I'm going to call that Y. Why? Because it's about the facilities only, not the zone. Okay, now we are going to our, don't forget Oxford comma, equations. equations. So I am going to keep the equations very simple. So that's why we are going to have a lot of equations here. First, we have our objective function, then the supply constraint. Then we are going to get a demand constraint. And then we are going to get, we are opening A, so I am fixing A. And then I'm going to fix B because we're opening that. And then I am going to choose. So I'm going to make a constraint about that also. Okay, now we can begin to write. So objective function, what is our objective function? We are trying to minimize the cost. So summation, oh, I always forgot, Z equals, if we put an E here, that means equal. If we put a G, that's greater than. And if we put an L, that's less than. So Z is going to equal to the cost summation of, so IJ, comma, and then XIJ times the cost, CIJ. Okay, and after each equation, don't forget to put your Oxford comma. So supply. So why did I put an I here? Because the supply constraint has to do with the facility. So how much a facility is going to supply has to do with the facility. So I'm using I there. Sum. And then obviously we are also going to use J now here because J is also going to increase. Xij, because we always have that, Xij. And then that's going to be less than or equal to the facility capacity. Facility capacity. Because you cannot, you cannot supply more than the capacity of the facility. And then, because we are using binary variables here, the most important part is I'm going to also multiply this with our yi value. And why we do that is going to be to get a more logical when we continue. Okay. I forgot the parentheses here. Let's close that. Okay. And then I'm going to my next equation. And that's my demand equation. Demand J dot dot sum. So because I wrote J here, I'm going to have to increase I also. So I'm putting I here. Xij again. Ij. And this time, this is going to be greater than the demand because what we are bringing to the warehouses should be more than the demand. And then dj. Okay, now I'm going to fix A. What I mean with that is, so I'm going to say Y, and then A. YA is going to, it's already open, so we always are going to have that. So I'm going to write it this way. And for the B also, I'm going to also write it this way. Y and then B. And this is also going to be equal to 1 because we opened this. This is already existing. And now I'm going to choose between J, C, and D. And how do we do that? I'm going to say C, and then I'm going to say plus, and then D. And this is also going to equal to 1. Why? Because I open definitely one of those, but only one of those. Okay, so that's actually the reason. This is the reason why I also put this one here. So this means if I open A, which I'm always going to open, I'm going to use this part. If I'm going to open B, I'm going to use this part also. And then C or D. If I open C, that part of C is going to be used. And if I open D, then the part of D is going to be used. So or C or D. Okay, for the end, because I'm now done with my equation, I'm going to have to make this work. So quantitative analysis, I'm just going to write QA and then all, and then we are going to solve QA. We are going to MIP, so mixed using MIP because it's mixed integer programming. And then what are we doing? We are minimizing Z. So what do I want to see? I write here by display. I want to see X. I want to see Y level of X, level of Y, and I also want to see Z. Let's see if I have any mistakes. I do. I'm going to get back. Okay, so there were little mistakes. Maybe you already noticed, and you were like, why are you doing this? So I forgot that I had changed D to DE here. So I changed that here also, and I forgot to equate this to 1. That's the only thing. So now we can look at our solution. Let's see, like here we can already see that the optimal solution for Z, so the cost is 1030, which was actually the same in the manual solution. In Northwest method, also in minimum cost method, we also found 1030. But let's see. Let's read the solution. Okay, look. So A to North, we send 80 units. B to North, we send 10 units. B to Central, 50 units. C to Central, 20 units, and C to South, also 60 units. So as you can see, because we opened C, we did not open D. So that's very important here. That's also why we did it a little manually. Okay, so thank you for listening today, and I hope you have understood a lot. I'll see you next time.